In this equation, we have one of our radicals on one side of the equation and everything else on the other, which is what we want. And this turns out to be a pretty simple problem, because once that situation is true, you are just going to square both sides. And when you do that, the radicals end up canceling themselves out, and you're left with x minus 5 equals 4x minus 29. And now it's a pretty easy equation to solve. We're going to subtract x from both sides. Get negative 5 equals 3x minus 29. Add 29 to both sides and get 3x equaling 24. Divide by 3 and x equals 8. And when we go back to plug it in to check, we have the square root of 8 minus 5. And we're wondering if that equals the square root of 4 times 8 minus 29. On the left-hand side, we have the square root of 3 equaling the square root of 32 minus 29. And sure enough, the square root of 3 does equal 3, the square root of 3. And so we know we have a good answer. So when you're solving radical equations, make sure that you get everything that's outside of that radical to the other side of the equation. So our first move here is to add the x to the other side. And so we'll have the square root of x plus 7 equals x plus 1. Now, since we're dealing with a square root here, we're still going to square both sides, but make sure you do exactly that. Make sure you're squaring both sides. So that means that we're going to have to FOIL this right-hand side, x plus 1 times x plus 1. So then we're going to get x plus 7 equals x squared plus x plus 1. Combine like terms on the right-hand side. X plus 7 equals x squared plus 2x plus 1. And now we just have to solve a quadratic equation. And if you remember correctly, the first thing to do on that is to get it all set equal to 0. So we're going to subtract the x plus 7 both of those terms to the right-hand side. And we're going to have 0 equals x squared plus x minus 6. Now, hopefully you can factor, and this one does factor, and that's an easy way to do it, or you can use the quadratic formula. But since this one factors, that's what we're going to do. So we're going to say 0 equals, and we're going to think of factors of 6 that can add together to give us positive 1. So that would be plus 3 and minus 2. We're going to finish this off by setting each factor equal to 0. And x equals negative 3 and x equals 2. Now we still have to check for our extraneous solutions. So let's plug both of these in and see what we get. So we'll plug in negative 3 into the original and see what happens. So we get negative 3 plus 7 minus a negative 3, and we're going to see if that equals 1. So that gives us the square root of 4 plus 3 equaling 1, and finally 2 plus 3, and that does not equal 1. So negative 3 is what they call an extraneous solution. Let's check to see if 2 works in our equation. So we get 2 plus 7 minus 2. Let's see if that equals 1. And that's the square root of 9 minus 2. And that becomes 3 minus 2, and that does equal 1. So we do know that 2 is an actual solution. Okay, so let's isolate one of our radicals on the left-hand side and move everything to the right-hand side, or everything else to the right-hand side of the equation. So we're going to have the square root of x plus 12, and that's going to equal the square root of x plus 2. And now we're going to square both sides just like normal, which means that we're going to get x plus 12 equaling, and again we're squaring sides of the equation, so you're going to have to FOIL, and I know this is a kind of a pain, but this is the way to get it done. So on the left-hand side, we have x plus 12. And when we FOIL this, we're going to get x plus 2 radical x plus 2 radical x plus 4. We're going to combine like terms on the right-hand side. And we'll have x plus 4 radical x plus 4. Okay, now of course we're still left with this radical, so we need to isolate it now. And that means moving everything else to the other side of the equation before we square it. So I'm going to subtract the x and subtract the 4. And this one actually kind of works out kind of nice because when we subtract x over here, that'll cancel that x. And we'll subtract 4 here, and we'll be left with 8 equals 4 radical x. We'll divide both sides by 4, so 2 equals radical x. And now we're going to square both sides. And what we have then is x equaling 4. We're going to check that to make sure it's all good. So square root of 4 plus 12 minus the square root of 4. I'm going to see if that in fact equals 2 or not. Right? 4 plus 12 is 16. Square root of 16 is 4. The square root of 4 is 2. And sure enough, that does equal 2. So this is our answer. Now, it could get a slightly more difficult than this, but not by much. You know, for instance, right here, it was nice that our x's canceled, but maybe they didn't. And then you'd have to square this whole side like we did up in this step. Okay, but you know, then it would just be solving another quadratic. You know, I guess it could be harder if you had the third root and you had to cube each side, and it could get pretty messy. But for the most part, these examples should get you in a good place.